Right, I know there's still people coming in, but we should probably, in the interest of time, get started. And it just hit 100. That was, for me, the perfect starting point. Wonderful. Well, good morning, good afternoon, good evening, wherever you are in the world. It's great to have you all here for this webinar. I'm Moni Böhm. I'm the Freshwater Conservation Coordinator at the Global Center for Species Survival. And today it's my great pleasure to welcome you to this webinar by Dr. Virgilio Hermoso on systematic conservation planning for freshwater. This webinar is organized by the FUNACTION Consortium in partnership with the Global Center for Species Survival here at the Indianapolis Zoo. Please feel free to use the chat to introduce yourself, so we'll get a little bit of engagement going. If you have any questions for Virgilio or any of the other panelists who will briefly talk about the Global Center and the project FUNACTION, please put these in the Q&A box in Zoom, and we will do our best to put these questions to our speaker at the end of his talk and answer your questions about what you're hearing in this talk. Before I hand over to Jennifer Anderson, who will briefly introduce the FUNACTION Consortium, I should probably do the same thing for the Global Center for Species Survival. See if I can move these slides along. The Global Center for Species Survival is a partnership between the Indianapolis Zoological Society and the International Union for the Conservation of Nature, the Species Survival Commission of the IUCN. The Species Survival Commission really is the largest commission of the IUCN and is made up of loads and loads of volunteer experts who give their time to advance species conservation work globally. It's generally kind of framed within specialist groups, and the link that we have to the project FUNACTION is via the recently formed Aquatic Fungi Specialist Group. Really, our role here at the Global Center for Species Survival is to support the work that these experts do for species conservation worldwide. This is just to give you some of the faces within our team. As you can see, we're kind of trying to cater to all of the different specialisms within the Species Survival Commission in terms of taxonomy and in terms of systems. My focus obviously is freshwater. This is why we're here this morning. We also have a plants and fungi coordinator who's also very interested in what the Aquatic Fungi Specialist Group, for example, does, and so on. We're here to help. If you want to find anything else out about the Global Center, then just drop me a line, drop the Global Center a line, and we'll get back to you as quick as we can. And with this, I should really hand over to Jenny to introduce the FUNACTION Consortium. Jenny,
hello, everyone. It's my pleasure to welcome you on behalf of the FUNACTION project. So we are funded through the Biodiversa Plus EU Biodiversity Partnership. And yeah, we have three main objectives in our project where we are overall working towards the conservation of aquatic fungi. So the three themes that can describe our project are foundation, conservation, and communication. For foundation, we're focusing on producing the foundational knowledge that we need to be able to build the foundational knowledge to make conservation planning possible for the aquatic fungi. We are committed to translate that knowledge into conservation planning and monitoring tools that we need to, again, foster the conservation of aquatic fungi. And communication, we're working towards to communicate about the aquatic fungi, their ecological importance, their rich biodiversity, and their biochemical potential. And I welcome you to learn much more about them at our website on X or LinkedIn. Moni, if you can change the slide for me. Thank you. So you're most welcome to check us out and follow us on X or LinkedIn, or to contact any of our partners in the 7 countries. We have 8 partners in 7 countries. And you know, I don't want to take more of Virgilio's time, but welcome.
Then I take over just a minute. Sorry, Moni. I think I can make that switch. Yeah, it's my pleasure to introduce Virgilio Hermoso López. Virgilio is a CSIC titular researcher at the University of Sevilla. where he's leading the environmental decision-making group. And his research is focused on assessments of policy and management efforts to halt biodiversity loss and on developing the data needed to make informed decisions with this goal. For instance, he is now leading and coordinating the Biodiversity Plus project Inspire, which is of the same cohort as FUNACTION that we have heard about. So the project Inspire that aims at developing a novel decision support framework to prioritize biodiversity management efforts across Europe. But Virgilio really kicked off his career with his PhD that he did at the University of Elva until 2008, where he assessed the ecological health of Mediterranean rivers, and with the goal also to work towards, to support decision-making for the spatial allocation of conservation efforts. He then moved to Australia for 6 years postdocing, where he contributed to the implementation of systematic approaches to conservation planning in freshwaters. And after that, he returned to Europe, in particular to Catalonia, where he was based at the Forest Science Center, and continued his work on freshwater conservation planning and was assessing the adequacy of European conservation policy. In 2021, he took position as a senior researcher at the University of Sevilla, again back in south of Spain. And also there, he's now a researcher for the CSIC. And so, as you can see, we have a truckload of knowledge and experience on conservation planning in freshwaters for you. And I'm very pleased and honored to have you, Virgilio, as our guest. And I'm excited to hear more about all of these topics. And I hand over to you. The floor is yours.
Thanks, Andreas. I would like to thank FUNACTION team for giving me the opportunity to do a really brief introduction to systematic conservation planning for freshwater ecosystems. It is probably more commonly applied and known for marine and terrestrial systems. So I would like this event to actually give a push to the application of these type of methods in freshwater systems. And I will try to demonstrate how you can actually use them to enhance the effectiveness and cost effectiveness of conservation efforts in freshwater systems. As you all know, freshwater biodiversity is highly diverse, especially if we consider the small surface where it develops. Freshwater ecosystems occupy a really tiny, small portion of the global surface, and still there are some taxonomic groups, like I'm just using some representative ones here, that hold thousands and thousands of species. I just learned, for example, today that there's already more than 4,000 freshwater fungi species described, and I'm pretty sure that there will be more coming in the next few years. But freshwater systems are not highly biodiverse, but are also really important for humans. We depend on our civilization is developed around freshwater ecosystems. We depend on them for things like water provision, energy production, materials, and also from a cultural, spiritual point of view, and for recreational activities. These intense uses that freshwater ecosystems have been submitted to over the last millennia has taken them to a really poor conservation status. In this study from 2010, it's already old, but still applies, from Boros Marti et al. We see that the conservation status of freshwater ecosystems globally is actually really bad. And in a more recent one, where Gunther Grill and collaborators evaluated mapped free-flowing rivers at global scale, we also see that we have completely transformed freshwater ecosystems around the world. And this has consequences in terms of conservation status of freshwater biodiversity. By far, this is the realm that holds the highest proportion of endangered species globally. Also, if we take a look at the European condition, we see that some taxonomic groups like freshwater fish or freshwater mollusks have large proportions of the species included in some of the IUCN 13 categories. Like, for example, we see that 44% of freshwater mollusks are either critically endangered, or vulnerable. So how are we responding to this biodiversity crisis globally, but specifically in freshwater ecosystems? Basically, the most commonly used tool to address this biodiversity crisis is by designating protected areas. This is the network of protected areas in the European Union. It's called the Natura 2000, and it currently holds more than 27,000 individual protected areas, covering nearly 20% of the terrestrial surface and about 9% of the marine surface. The question is, has this massive effort been effective? Are we actually hitting the target, and are we managing to recover biodiversity? The thing is that if you're familiar with, for example, global indices like the ones developed by WWF, we see that biodiversity continues to decline, especially in freshwater systems. Like if we take a look at the evolution or how the populations of freshwater species that have been monitored since 1970, we see that there has been a decline over 80% in some cases. In the case of the European Union, we do a monitoring effort every 6 years of our biodiversity, habitats, and species. And we see that despite the effort at designating protected areas, we haven't been able to actually halt biodiversity loss. We continue to see biodiversity declining across the European Union. Of course, there are some species, particular species, where we have seen some recovery patterns, but overall, on average, species and habitats continue to decline despite the effort. What could be the reasons behind this lack of effectiveness of our massive conservation effort? I could spend the whole webinar just talking about potential factors behind this, but I would like to focus just on 4 here, especially because these 4 ones are factors that we can actually address through adequate planning, which is the target of my talk today. Some factors behind this poor effectiveness of our conservation efforts could be the lack of representativity. Is our network of protected areas covering the spatial distribution of the species that actually need management? Second one, inadequate spatial planning. Is the spatial configuration of our network of protected areas good enough for halting biodiversity loss? Next one is insufficient resources or inadequate use. We know that halting biodiversity loss is limited by the amount of efforts and money budget that we have. But unfortunately, sometimes we don't even use it adequately. That can be planned to enhance the effectiveness of our conservation efforts. And finally, poor social engagement. During the first part of my talk, I'm going to focus on the first 2 factors, lack of representativity and inadequate spatial planning. So let's take a look how we've been distributing our conservation efforts, specifically how we've been designating protected areas. I'm going to show you some pictures of protected areas that I have picked from all around the world. And I would like you to think about things that they all have in common. I know that evaluating this from just one picture is complicated. And I can warn you that all of them have water, but just simply because of my professional bias. First one is a national park in the US. Another one in Germany. Another one in Northern Australia. this one in the Amazon. This one is in the Pyrenees, northern Spain. And another one from South America, from Venezuela. So there's a common pattern to all of these pictures that I just showed you that are representative of the global network of protected areas. And if you have realized, we can see that they all have high aesthetic value, low productivity potential, at least in their current condition. So we don't see massive infrastructure to actually exploit the natural resources, for example, in those areas yet. They are all located kind of in remote areas. And all this is kind of giving us a hint that conservation efforts have been traditionally allocated, trying to reduce potential conflict between biodiversity conservation and other human uses. Basically, we're pushing conservation efforts to areas where we have less interest or with lower economic potential. And this is what we call opportunistic or ad hoc decision. Basically, seems like we have not used biodiversity per se when making decisions where biodiversity needs to be managed. And I'm not saying that those places that I just showed you don't have value for biodiversity conservation. I'm just saying that the decision was not made based just on the biodiversity values, okay? And this has implications. For example, if we look at this study by Bob Bracey and colleagues in New South Wales in Australia, we see that conservation efforts have been allocated mostly to those areas that are in around mountains. I would say, as you see, I hope that you can see my mouse. You see that we've been mostly allocating protected areas in areas with high slope and low fertility. The same happens in Europe. I'm just showing you the extent of Natura 2000 in the Iberian Peninsula, Spain and Portugal. And we find exactly the same. We're protecting areas in high elevation and high slopes, basically in the mountains, far from where humans are. That spatial allocation has implications for the effectiveness of conservation efforts. For example, in terms of representativeness of the network. For example, in the Iberian Peninsula, we have already covered 25% of water of all the terrestrial area. You might think that that's a lot, and we must be doing really well in terms of covering the spatial distribution of our species. However, for example, this particular one, which is a critically endangered freshwater fish endemic to the Mediterranean coast of Spain, we only have a few populations remaining. Only 7% of those populations are actually covered by Natura 2000. But the situation, it gets even worse. There are some species that never occur within Natura 2000. And it's really interesting because we actually made the effort to distribute this 25% randomly thousands of times. And these type of situations where there are some species, for example, that never occur within the network, hardly ever occur. So it seems like the spatial distribution of our conservation efforts are not better allocated than random. And that's not only specific or particular to the Iberian Peninsula. We see the same, for example, in studies all around the world. For example, this study by Chessman in the Murray-Darling Basin, or for example, in the US, across the US, these two studies focus on freshwater fish, but are not only vertebrates. For example, we see also in the Iberian Peninsula again that the representativeness of the network of protected areas is really bad at covering, for example, in this case, the distribution of aquatic beetles. The consequences of opportunistic decision making is expands beyond representativeness. It's also it influences the configuration of the adequacy of the spatial design. I'm showing you here, I just zoom in a particular area in Spain to demonstrate, to give you some examples of really common problems that we see all the time. So for example, freshwater ecosystems, like rivers in particular, are very often used to delineate, to set the boundary of protected areas. This is not completely effective for freshwater biodiversity conservation, because by protecting just one side of the ecosystem, we're not securing that the biodiversity that we want to protect in that particular area will persist, because it's subject to potential threats coming from the area that is not protected or managed for conservation. Freshwater ecosystems are also tend to be used as corridors for, and not specifically designed for freshwater biodiversity. Most of the time are designed or designated for terrestrial biodiversity. Again, by managing this narrow strip of land, we're not securing effective conservation of this protected area for freshwater biodiversity. And then overall, we see really poor overlap between the boundaries of protected areas and the hydrological limits of our freshwater ecosystems. Again, this might be behind why protected areas are not so effective, or have not been so effective for freshwater biodiversity. So how can we use a systematic conservation planning to improve both representativity and spatial design of our networks of protected areas? So before I go into spatial planning itself, I would like to give you another example. Like if we wanted to improve representativity, of course we need to use those species and habitats that we want to manage, protect, when we make the decision where we are going to put the efforts. However, traditionally, we've used a method that might not be the most ideal one either. And with this, I mean that, for example, very commonly, I've seen that people use indices, biodiversity indices like richness, number of endemic species, endemicity, rarity, and so on, to make the decision. So basically, you map the distribution of your species, you overlap them all, and then decide to put your conservation efforts in the areas where more species overlap in the distributions. I mean, this is good because at least we're using the distribution of our species for making decisions where to preserve them or where to manage them. However, it's not free from problems. And if, for example, in this particular case, we've got 7 species, we've got 5 rivers, and we cannot protect all of them. Let's say that we could protect 2 of them. If we used richness in the richness for making our decision, we would go and protect rivers A and B, right? Because these are the richest in our area. However, if I show you the distribution of our species by protecting rivers A and B, we're actually kind of duplicating our conservation effort for 5 species, but we would miss completely 2 species. And it's actually only by protecting rivers D and E that we can secure that we're managing a population of at least one population for each of our species. So this is what we call complementarity. You see, these are not the richest rivers in our study area, but they complement each other perfectly. And this is something that we always try to do with systematic conservation planning. The second key principle in systematic conservation planning is cost effectiveness. If we have different options to achieve the same representativeness, we would always try to go for the cheapest one, okay? But when designing a network of protected area, it's not only about representing biodiversity. We also need to make sure that that biodiversity we aim to protect will persist in time. And to make sure that it will persist in time, we need to take into account for the ecological processes that sustain the biodiversity that we see today. And for example, and that's key when we are designing our networks of protected areas. One of the key aspects in freshwater ecosystems that drives important ecological processes is, for example, longitudinal connectivity. Longitudinal connectivity is important for maintaining processes like seasonal migrations, the transfer of energy and material along the systems, or even to make sure that our conservation efforts are effective. Because, for example, if we wanted to protect these populations here in this particular area in the catchment, but we didn't take into account that there might be threats propagating along the network, our conservation efforts in that area would be completely ineffective. So it is really important that we plan at the adequate scale, accounting for those ecological processes that determine the persistence of the biodiversity that we're interested in. How do we address this? I'm going to start with a really simple example. Let's say that we had decided or had identified that this particular grid cell here it's really important for conservation purposes. For example, we've got a population of an endemic species that does not occur anywhere else. How do we make sure that the spatial design is adequate? So by designating a protected area just focus on that grid cell, again, as I said before, the grid cell itself is subject to threats propagating from outside. So it's quite vulnerable to the impact of threats. So we might actually want to also protect those grid cells that are in immediate contact with that target grid cell, or even expanding it further. Of course, I'm not suggesting that grid cells is the best spatial approach for freshwater ecosystems. And actually, when we do conservation planning in freshwater ecosystem, we normally use different spatial units like the rivers themselves, or for example, subcatchments. And again, we can characterize connectivity quite well between different river reaches, or between different subcatchments, and use that information to inform our spatial planning tools. So the spatial configuration of our networks of protected areas are adequate for freshwater conservation purposes. In terms of tools, we've got a great variety of tools. I'm showing here just four of them. They all publicly available. You can download them for free. There's also a lot of training materials, even training courses organized every year that can help you learn how to use them. I'm going to focus the rest of my talk on one of these tools, which is Maxan. It's probably one of the most commonly spatial planning tools used worldwide. I'm not going to go into detail. Don't panic. I'm not going to go in detail into the mathematics behind Maxan. I just want you to understand that it uses an optimization algorithms. Basically, it tries to optimize an objective function where we've got three different parameters. A parameter related to cost, so we want to minimize cost. A parameter related to connectivity. Actually, I shouldn't call it connectivity. If my mathematicians colleagues heard me, they would kill me, because this is more related to lack of connectivity, actually. So it's a penalty for not achieving connectivity. And then another component of the objective function is targets. Targets is how much I want to represent within my network of protected areas of each of my species or habitats. Okay. So just to give you some examples. This comes from this first example comes from Northern Australia. So basically here we mapped the distribution of 209 species, including fish, aquatic birds, and turtles. And then we asked, what would be the minimum set of river reaches or subcatchments that we would need to include in a hypothetical network of protected areas, so all of our species are adequately represented, okay? And these spatial planning tools help us identify, for example, in this case, that hypothetical network of protected areas. Just to show you that by using all the principles that I showed you before about representative complementarity, cost effectiveness, and also connectivity, we can manage to actually design networks of protected areas that, as you see here, for example, are really well at covering longitudinal connectivity or connectivity along the coast, that it is important, for example, for movement of water birds. That's a particularity of this case study. We can also ask Maxan, how can we complement a network of existing protected areas? So in the previous example, we actually planned for a network of protected areas from scratch, as if there was nothing existing already on the ground. But we already have protected areas. So we can also incorporate in our spatial planning exercises existing protected areas and ask for a minimum set of additional areas that should be incorporated into that network. So we improve both representativeness and also the adequacy in terms of spatial connectivity, for example. In the case of the Natura 2000 network in the Iberian Peninsula that I showed you before, so we also try to identify this minimum set of additional areas that should be incorporated into the Natura 2000 in the Iberian Peninsula. And we found that for improving representativeness and also spatial design. And we found that it should be, the network should be expanded to cover up to 30% of the Iberian Peninsula, which by the time in 2015, we thought that it was too much, too crazy. We could not propose something to the regional governments, but now we know that it's actually realistic, because with the new European biodiversity strategy, we have committed to actually expand the network of protected areas to cover up to 30%. Ecological processes that we can incorporate in spatial planning exercises do not only constrain to longitudinal. Ideally, if it was relevant for your biodiversity and it was really important for the biodiversity that you want to manage, to incorporate additional processes, for example, like this lateral connectivity between the river channel and the floodplain, you can also integrate that in your analysis, like Vanessa Reyes and colleagues demonstrated in the Amazon. You can also incorporate connectivity between surface and groundwater, like Simon Linke and colleagues demonstrated in Australia. Basically here, you creating protected areas. So for example, if you needed to protect a particular surface freshwater ecosystem, this also forces the selection of the aquifers that actually feed that surface ecosystem that you're interested in. And also temporality, seasonality. You can incorporate seasonality. This is really important in temporal freshwater ecosystems that probably cover around 50% of the global distribution of freshwater ecosystems. So far, I have just focused on biodiversity, but we need to manage biodiversity in landscapes, seascapes, riverscapes, where there are other activities, where there are humans doing things, and there are other interests. This is why we have also tried to work on integrating additional objectives into our spatial planning exercises, not only biodiversity, but other things like energy production, irrigation, recreation. Basically here, the question that we try to address is where can we allocate different management efforts to actually get everything in a limited area. Basically here, we will need to identify priority areas for biodiversity conservation, but also other things like some ecosystem services that can co-benefit biodiversity conservation, and where we should be allocating, granting access to things like irrigation, energy production, or recreational activities that might impact biodiversity conservation. So how do we actually organize this spatial puzzle? To demonstrate how it can be done, again, this is another example from Northern Australia, where we map the distribution of our species and for ecosystem services, extraction of groundwater for irrigation, recreational fisheries, carbon retention and flood retention and also perennial waters, which was really important as a cultural service for Aboriginal people in the area. So we can incorporate all those different objectives and then ask these spatial planning tools, okay, where can we actually grant access to services that might impact biodiversity conservation, or where we should be focusing our conservation efforts for biodiversity. I won't go much in detail on how we did it or explaining what the map means, but just to give you an idea, this could be something like or could help or could inform catchment management plan, because we know where we can grant access to impacting land and water uses, and where we should be, or where we should be putting our conservation efforts. And finally, just really briefly, we can also use these spatial planning methods for planning restoration, not only conservation. And just to give you an example, another example from the Iberian Peninsula, in the Tagus River catchment that flows from central Spain to Portugal, to actually the mouth of the river is Lisbon is in the mouth of this river. Basically, in this case, we were interested in demonstrating how to use these spatial planning tools for recovering connectivity. We identify nearly 1,000 barriers across the catchment. All these dots that you see here, some of them were thought to be not removable, basically, which is represented by the triangles. Basically, these are really large hydropower dams that we could not realistically propose to be demolished. And but apart from that, we had a large variety of different barriers, from weirs to gauging stations, really small barriers that would be really easy to remove. Then we characterize all of them in terms of passability, because not all of them are completely impassable for our freshwater fish. There are actually some freshwater fish species that can move over the barrier, so it wouldn't make much sense to remove a barrier that would not give us benefit in terms of improving connectivity. So we assess the passability of all those barriers for every single of our freshwater fish species, whether it was removable or not, and the potential cost in a qualitative scale. So we didn't have an estimate of how much what would be the economic investment that we would have to make to remove the barrier. It was just whether it was super expensive, reasonably expensive, medium cost, and very low cost. And then we ask, well, which of those barriers should be removed so we can actually reconnect populations for all of our freshwater fish species, minimizing the potential cost. So we can actually identify here in black which are the barriers that we should remove or make permeable to achieve a given proportion of reconnection for all of our freshwater species in the catchment. So for example, I think in this solution that I'm showing here, by removing these black dots, these barriers, we will be reconnecting, which is less than 50 barriers in the catchment. I think that we could reconnect up to 25% of the connectivity that has been lost over the last century in the catchment. We can do that not only for one threat. Here, the threat or the impact will be barriers. We can actually do that simultaneously for multiple threats. So that can help us address multiple threats simultaneously. Again, I don't have the time to go in detail on how to do that, but basically this is indicating us where we should be implementing what type of management actions, so we can reduce the current impact on all of our freshwater species by a given percentage. I think in this case it was a 20% target. So for all of the freshwater fish species in the catchment currently impacted by these 4 threats, we wanted to reduce that impact level by 20%. That would be those would be the areas where we should be investing our, for example, eradication efforts of some invasive species. I hope that even though that it was fast, this gave shed some light on how we can actually use spatial planning methods to enhance the effectiveness of our conservation efforts and improve to actually help us bend the curve of biodiversity loss that we unfortunately continue seeing decline. And with this, I finished. I thank again the FUNACTION Consortium for giving me the opportunity to give you this talk today, and all of you for attending.
Thank you, Virgilio, so much for this beautiful seminar. And we will now start with some questions from the audience. And we have already a first one from Jacob Harmon. And the question is, in your experience, have there been decisions made based on protecting a keystone species or umbrella species? And do you believe that they are a viable ecological tool to increase biodiversity when making management decisions?
Mm-hmm. Yeah, that's a really good question. Yes, the answer is yes. There are examples where some key species that offer this umbrella coverage to other species has been used in the real world, not only in academic exercises. I know lots of examples from terrestrial systems, for example, but in freshwater systems we do have some. Like, for example, in the Amazon, you know, I forgot the name, the common name of the species, but Arapaima gigas is a piracucu, I think it was called. It's a really large freshwater fish, and there have been some protected areas or no-take zones designated for the species, and it has actually shown benefits not only for the species itself, which is actually really good news because it was in really critical condition, but also for other species that co-inhabit with that one. Whether I would recommend it or not, you always have to be careful because, as I showed before, by protecting the areas where we find these key species, we offering this umbrella effect to probably only a subset of the other threatened species. So you would always need to complement that with some additional areas to make sure that your conservation efforts are fully representative.
Thank you. I remind everyone that is with us today that please, if you have any questions for Virgilio, just to put them on the Q&A section. And in between, we don't have other questions. I would like to make you one question, Virgilio. So when we do this kind of planning, how can we incorporate predicted future changes? So I'm thinking about climate change and how specifically in some areas why we might start to see more the drought events, and maybe for freshwater ecosystem, this is really, really important. How can we integrate this already in the planning for the future? Because if we are investing now in expanding some areas that maybe in 20 years will be mostly dried, this might not be very effective. So what is your opinion on this? Thank you.
Yeah, that's another really good question that I didn't have the time to touch on during the talk. So thanks so much. We can do that, and we have actually done some academic exercises incorporating future distribution. So the examples that I showed are just based on current distributions. So wherever we see the species right now, but we can actually integrate in our spatial planning exercises current and future. So by integrating future and setting targets, representativity targets for the future as well, you're forcing these spatial planning tools to identify priority areas, not only for current distributions, but also for the future. Because of the complementarity, if you actually, the ideal scenario would be to actually be able to protect all of your species in refugia. In refugia, a refugia would be an area where you see the species now, but you actually see it in the future as well. So the population will persist in time. That's fantastic, because if you designate that area as a protected area, that protected area will be kind of resilient to the future change. Okay, unfortunately, this is difficult because with the current distribution of protected areas, it would be difficult to also protect all the future needs. So that's why we need to incorporate explicitly the future distributions. Just to give you a really interesting example that we just recently published a couple of months ago. Here in the Iberian Peninsula, we've got highly endangered populations of freshwater mussels. And these freshwater mussels depend on freshwater fish to actually survive and move. So what we did, we projected the future distribution of these freshwater mussels under different climate change scenarios. We saw that actually the habitat suitability for these mussel species changes radically in time. So in the future, the suitable habitat for these species is located in very different rivers than where they currently are now. So if we want these species to persist in time, because they depend on fish to move, they basically depend on the fish to adapt to climate change. So if we want these populations of freshwater mussels to occur in the future suitable habitat, we also need to let fish to move to those future suitable habitats. Otherwise, the mussels themselves will never reach there. The problem is that we actually see, as you saw in this talk, we have thousands, tens of thousands or hundreds of thousands of barriers. So that's going to limit a lot the adaptive capacity of mussels, because they won't be able to actually reach the future habitat. So something really interesting to start working on is actually not only on identifying future important areas for conservation, but also we need to enable the adaptive capacity of the species. So we need to let them actually reach those future important areas.
Thank you.
We've got another question from Stefan Mutel. Sorry if I kind of pronounce it wrong. How is this really nice modeling academic work transferred to stakeholders and decision makers and politics? Do we need any kind of additional arguments or tools to essentially make this real?
Another good question. Yes, it is true that I have only shown academic exercises, but I've been lucky enough to be part of decision-making processes in the real world, not only in academia. I have to be honest, and these applications to the real world, real decision-making, is not super widespread, but we do have some examples that I hope that get more common in the future. So one of these examples I actually saw that there was someone from Bhutan. So I participated in a planning exercise in Bhutan a few years ago, where the government was interested in designating wild rivers for no hydropower development in the future, and we used these spatial planning tools to identify which of the rivers in Bhutan were the ones with the highest conservation value for being designated as no hydropower development in the next century at least. And it worked. It has been implemented, and I think it's actually working. I could give you some more examples, but and if we have time, I will do it later. But I prefer to give the opportunity to other questions.
Thank you. We have another question from Phil Boone. Your talk was strongly focused on species conservation. That's fine, but if we accept the much broader CBD definition of biodiversity, there is surely a strong case for conservation of some fresh waters that may be species poor, but near natural. For example, high altitude, nutrient poor, high energy streams. Have you used Marxan to identify those types of habitats?
We definitely have incorporated species poor habitats in Marxan, for sure. And this is one of my personal battles with some of my colleagues working also in conservation science. And it's because, as Phil said, there are some species poor systems that are really important for conservation purposes. They are really unique. And if we use scoring criteria, like normally done, as I showed, things like making decisions based on richness, for example, those areas will never appear as a high conservation value. By using Marxan, for example, because of the complementarity, if those areas hold species that are unique, that do not occur anywhere else, they appear. These areas must appear as priority for conservation, for sure. And it is the case. For example, here in Spain, we did some spatial planning analysis in the Guadiana River catchment, where not only the main stem of the Guadiana, where we've got the highest species richness, was selected as a priority. We actually found that there were some small tributaries in headwater systems that were actually key and really important for biodiversity conservation in the catchment.
Thanks, Virgilio. There's a question from Raquel Costa. She says, first of all, thank you for the presentation. How can we know and discuss about the real status of biodiversity conservation if some groups of organisms are more studied than others? I feel this is a good question also for FUNACTION, specifically aquatic fun. For example, there's better systematization of data. There's better data on freshwater fish than aquatic insects, mainly in tropical regions.
Yeah, this is the downside of these approaches. But I think of any decision-making process, to be honest, like making decision with perfect information, it will never happen. So what we normally do is to try to incorporate as many taxa as possible, so a wide variety, diversity of taxa, assuming that they actually represent, so they are good surrogates for other things. If you're not completely sure, another thing that I would recommend you doing, that it's actually been done quite commonly in marine systems, is to use habitats or environmental gradients as an additional thing to be represented in your conservation plan. So using the logic that if you maximize the diversity of habitats or the diversity of environmental conditions within your management priorities, you will be also offering opportunities to species that you have not identified or don't have data for, you know? By doing that, you are kind of giving the opportunity for species that have not been explicitly used in the spatial prioritization to be actually represented in the plan. But I definitely agree with you that most of these conservation planning exercises are based on vertebrates. Hardly ever we use invertebrates, and nothing to say about fungi, like FUNACTION is actually targeting. So that's why I think this project is really relevant to demonstrate how it can be done, and hopefully be the example for future planning, conservation planning exercises.
Thank you, Virgilio. We have another question from Rebecca Tarm. She says, well, first of all, thanks, Virgilio. Could you reflect a little on the challenge of addressing representativity using species and representativity based on ecosystem eco-hydrological types?
Okay. Yes, as I said, I think my answer is related to what I said before. both are legitimate ways of trying to answer the problem. You know, by using species, you know that you're actually covering whatever species you incorporated in your planning exercise. By using environmental surrogates, what you're doing is to try to represent things that might actually sustain a diversity of biodiversity. Okay, so by maximizing the coverage of different hydrological regimes, for example, from really permanent to temporal systems, you kind of maximizing the coverage of a range of conditions that hopefully it will also help you cover biodiversity. My personal preference is to always use biodiversity whenever you've got the data, species, habitats, any genetic diversity. For example, I didn't talk about genetic diversity, but you can also integrate genetic diversity in these planning exercises. Because these are the targets, these are the features that you want to manage and you want to persist in time. But if you don't have the data for that, I think it's completely legitimate to actually use surrogates for that.
Thank you. A question from Mark Day, which might build a little bit on Raquel's question earlier on. I'm not entirely sure. We'll see what you think, Virgilio. Where one is facing major gaps in the biodiversity data over large areas, for example, for historic reasons, what do you see as the best tools for rapid assessment that will then enable spatial planning analysis? So really kind of what would be the practical steps, right, to take? If one is limited on taxa to be assessed, do you have guidance on optimal value? That's the question.
Yeah. Again, I think I will repeat myself. I would always recommend using biodiversity data. It's just simply because those are the objectives. Those are the targets of your management effort. But I understand, and I have faced exactly the same problem in areas like the Amazon example that I showed before. It was really hard to get full coverage of species across the whole of the Amazon. I would say that there are, so whenever you cannot use taxa, spatial distribution of your taxa, I would recommend using surrogates for that. And again, using environmental variability. You know, you can map. We've got global maps of habitat types. We've got maps of any kind of environmental gradient. You know, altitudinal gradient, slopes, and so on. By using those in your spatial planning process, you're maximizing the diversity of habitats that you're incorporating in your spatial planning, in your spatial recommendations, your priority areas. We always have there's always the uncertainty on whether those habitat gradients that you used are actually the adequate ones for covering, for representing, or being surrogate for your biodiversity. So you need to be really careful with that, because this is something that we also tested a long time ago on using different environmental gradients. Whenever you don't have data, what happens? Well, let's try to use environmental gradients. We actually found that sometimes those environmental gradients are no better than at helping you make decisions than random. And the simple reason is because those environmental gradients that we found really bad were so bad in terms of identifying priority areas for conservation, simply because they were not the drivers of biodiversity patterns. So you really need to make sure that those environmental gradients you use are actually the ones driving biodiversity patterns, species distribution, habitat distributions. Otherwise, your decisions won't be better allocated. So your conservation efforts won't be better allocated than random.
Thank you, Virgilio. We have another question from an anonymous participant in our seminar today. And the person asks, as countries are developing their plans for achieving the 30 by 30 framework, so achieving 30% protected areas by 2030, is there a consortium of freshwater systematic conservation planners that could be readily consulted where there is a gap in capacity at national government levels?
I wish. I'm not aware of such a thing. I think it would be really valuable, especially because freshwater ecosystems and biodiversity have been traditionally overlooked in decision making. This is one of the reasons also why, for example, the Natura 2000 is so bad at representing the distribution of freshwater species. So I wish that if there was actually a consultancy, a group of people that governments could actually consult. From a personal perspective, I've been actually involved in a few planning exercises for the Spanish government, but I don't think is a common pattern. I think that normally decisions are still dominated by opportunistic approaches.
Thank you so much, Virgilio. We do have more questions. Unfortunately, that we have time. We'll definitely scan your questions after this webinar and pose them to Virgilio, maybe in a follow-up, if there's anything else that needs to be addressed in our follow-up communication about this webinar. Also, we will have this recorded, so we will share this out. In the meantime, also, I am sure it's fine, Virgilio, if folks get in touch with you and ask questions.
Yeah, sure. Yeah, sure. I have my my email account on the last slide, so please feel free to email me if you want to get access to any of the papers that I mentioned during my talk, or if you have a question, an interest, or anything, please reach out. I'd be really happy to be in touch with you.
Excellent. And the same goes for any questions you have about FUNACTION, specifically about the Global Center. Reach out and we'll try and help out as much as possible. Thank you very much, everybody, for attending. I'm sure you all agree this was a fabulous webinar. Thank you very much, Virgilio, for giving your time and giving your expertise and sharing all of your thoughts with us. That was really, really useful. And I hope we can organize maybe a follow-up webinar in the future.
I'd be happy to do that.
Excellent. It's now recorded, so that will happen. Thank you very much, everybody, and have a really good day.
See you. Have a good day. Bye.
Thank you, Virgilio.